Okay, so I'll get started with a short introduction, and I think by the time we get into the first project, we should have some more participants in the room. But first of all, it's great to see you all here today for the first public event for the resample MES CoBraD and retention projects. I'll start by introducing myself before I hand over to the projects and we can really get into the content of today. So my name's Oliver Blake, and I work for LIBA, which is a European Association of Research Libraries. We are a project partner in the MES CoBraD project, responsible for stakeholder engagement, hence my involvement in this session. As I already said, this is the first public webinar for these three projects. The collaboration comes from the fact that they all stem from the same funding stream within Horizon 2020, and you'll be hearing from them all today. But before we get into that, I'd just like to go through some house rules for the participants we have. This webinar will be recorded. This was on the sign-up form, and you all gave consent to this. For this reason, I would like people to keep their cameras off and keep the microphones off for the continuity of that recording. If you have questions throughout the session, please place them in the chat. We have someone who's keeping an eye on the chat, and I can relay questions to the speakers. And before I hand over to the first project, just a little bit of an overview of what we'll do today. So for the first hour, we'll hear from each three of the projects, and they'll introduce themselves, discussing the medical context and issues around this, before looking at the technical solution which the projects are busy developing. And then in the final hour, we'll go into a discussion section. This is where we'll have room for audience questions, and the projects can communicate with each other about challenges they're facing, similarities, and how they see the future going. So without further ado, I will hand over to our first project of today, the MES CoBraD project, and I'll let Christos and the team from that project introduce themselves.
All right. Hello, everyone. My name is Christos Danos. I am a research director for the Decision Support Systems Laboratory of the National Technical University of Athens, Greece. I am the coordinator of the MES CoBraD project, which stands for Multidisciplinary Expert System for the Assessment and Management of Complex Brain Disorders. The project has a duration of 36 months, starting from April 2021 and ending in March 2024. The consortium consists of 14 project partners from 9 European countries and Israel, ranging from universities, research and medical institutes, university hospitals, ICT industry partners and SMEs with expertise in medicine, engineering, computer science, social health science, ethics, law, marketing, and communication. We have tried to strike a balance between medical and technical partners, with an additional focus on having expert support on legal and ethics considerations. The consortium can be both robust and flexible depending on the issues addressed, while bringing a wide range of expertise and methods of work. The general idea behind the MES CoBraD project is between the problem which it tries to address, which is that millions of Europeans of all ages live with brain disorders that threaten their quality of life and also impact the sustainability of the health systems where they are treated. The proposed solution is that the MES CoBraD project aims to improve the diagnostic accuracy and therapeutic outcomes of complex brain disorders, such as epilepsy, dementia, and sleep disorders. To do this, it will combine real-world data from diverse populations from varying backgrounds through cost-efficient and fast protocols, and the expected impact is that the project will draw on expertise in medicine, engineering, computer science, among others, to ultimately help improve the quality of lives of those living with such disorders, caregivers, and society. To get into the details of the scientific part of the project, We continue the presentation with Dr. Eliseos Karagiorgiou.
Hi, I'm Eliseos Karagiorgiou. I'm a neurologist, behavioral and sleep neurologist, and scientific director at the Neurological Institute of Athens. So talking about addressing clinical and scientific challenges, first of all, the clinical challenges we try to address through this project is issues that have to do with difficulties in diagnosis, so be it underdiagnosing complex brain disorders, as Christos said, neurocognitive disorders, that is dementias and other cognitive disorders, sleep and circadian rhythm disorders, and epilepsy. Furthermore, there's issues that have to do with difficulties in diagnosing comorbid elements in these disorders. When one exists, we often forget to account for the other. And the issue here is significant because there's a very high coexistence between these disorders. And not only that, but should you have one and have a second one, or should you have a second one, your prognosis on the first one is worse. Furthermore, we don't have treatments, so etiologic treatments in a lot of them, especially when we think about degenerative dementias, for example, or we lack very effective treatments in a lot. So these were some key challenges to address as far as clinical challenges. There, for some reason, the slide has moved up, or the figure has moved up. There's also another element that has to do with the need to assess people through expertise that is often lacking. So when you go to see your general neurologist, oftentimes they will not be an expert in epilepsy or sleep or neurocognitive disorders. So how do we leverage such expertise? And that's where the expert system comes in order to help guide even the quasi-expert. And furthermore, there's a parallel path that has to do with research challenges, where within the spectrum of complex brain disorders, we often don't account for certain multidimensional elements, as we said before, those interactions between or within complex brain disorders. We have several failed, costly clinical trials. From time to time, you may have heard about trials in neurocognitive degenerative disorders, and also the expertise that individual centers have is often not integrated. There are some consortia, but it's often difficult to work together. So to that extent, on a scientific objective and success criteria for us, first is, how do we improve early, accurate, and comprehensive diagnosis in these disorders? Furthermore, how can we improve our prognosis? If you are given a diagnosis now, can you be told what to expect in the years to come? And then from a therapeutic standpoint, can we improve both identification of efficacious treatments, not necessarily develop new treatments, but perhaps there are medications that have been used for other conditions, and we can see how they can be how they can prove useful for the specific CoBraDs, but also reassess the safety of existing ones that have been approved. So in a real world practice, can we follow through on whether a medication that may or may not be expensive or may or may not be efficacious, are there also safety issues with it? And finally, the holy grail for us is can we develop a first instantiation of an expert system to guide clinicians through their day-to-day life? And in parallel, all these go beyond just the clinical and research component. There's also a very important societal component of objectives. How do we exchange data between us? Ethically, securely, strengthen the health systems that are involved, private or public, in different settings across Europe and Israel. And then how do we engage the stakeholders, the society at large, to contribute both through ideas and needs, but also in giving us feedback and keeping track of what we do. And then all of this under an ethical and legal framework. So in that sense, we look at real-world data, the real-world data of data in practice. We have 8 categories of data, from questions and questionnaires that you answer in a clinical visit, neuropsychological test of paper and pencil, imaging, sleep studies and actigraphy, biological markers, and also certain medical device, such as PAP device data. And then wearable technology or nearable technology that is growing more and more in the recent years. And then use that within the modular platform for data collection, representation, analysis, and feedback, and have four main pilot use cases. The first one is, can we improve deep phenotyping of complex brain disorders through more comprehensive protocols? That could be done even outside the platform itself. But then, can we use advanced analytic tools, both for improving that deep phenotyping, so that's where the platform starts to come in, and also repurposing and assessing therapies. And in the end, the platform itself having an expert system that can guide next steps in assessment and management of CoBraD. So in that sense, we collect data from a real-world practice in our patients. And we have modified the protocol. Parts of this protocol was implemented even before at the Neurological Institute, and has expanded both within our institute, but also across Rabin Medical Center in Israel, São Paulo in Barcelona, and King's College in London. And it means that when a patient comes in, to have this comprehensive assessment, they see a physician, they do neuropsychological testing, they have a wearable actigraph for a week where they also fill out a sleep metabolic diary. At the end of that week, they have a sleep study. And before and after the sleep study, we do cognitive tests, very brief ones, because as we start to see, they may be even equally or more sensitive to certain aspects of cognition. And also we do blood draws before and after sleep. And within that framework, as people have the need, or should they have the need for a PAP device or imaging, or if they have a wearable device, we collect that data as well and integrate it within the platform. So in that sense, we create a multidimensional picture of a person, irrespective of the initial reason they came to clinic, sleep, dementia, or epilepsy disorders, and account for the between real-world data interaction, but also between condition interactions, and follow over time. And in this way, not only are we looking at clinical data, but also at social parameters. Do people have access to data? If an MRI is missing, is it because they lack insurance or other components that predict outcomes for assessment? And in the end, as a first instantiation through the end of this project is to have an expert system. An expert system practically is a guide to clinicians that can integrate both data collected through this protocol, but also and through a knowledge base that exists from guidelines and diagnostic criteria, and then guide based on your initial step, what information do you have at the beginning, next steps for diagnosis and potentially management. And that expert system by the end of the project will be assessed for its accuracy and validity, and then improved over time. That's it. Antonin.
Yes. So let me switch on everything and take control. Okay. So good morning, everyone. My name is Antonino Sirchia. As you can see in the slide, I'm the technical coordinator of the project, and I'm working for engineering Ingegneria Informatica, and I'm based in Italy. So to start talking about the technical solution of the MES CoBraD project, we have to go through a couple of key points that guided us in designing the overall platform. Those key points are the microservice-oriented architecture, and we will see why we adopted this pattern. The cloud-native platform, distributed deployment, edge cloud continuum, continuous integration, and the methodology that we used, that is Agile Scrum. Those are the key points that guided the entire designing of the technical solution that is the foreground of the project. I said MES, microservice-oriented architecture. For those who don't know what it is, a microservice-oriented architecture is a pattern that is widely used to design highly scalable architecture. It consists in not creating one single component that is deployed all at once with all the functionalities inside, but it depends on the composition of the functionalities of the solution in several components, let's say n components. Each component can be composed by n microservices. It depends micro building blocks, let's say, that creates the overall functionality of each component. This approach as one of the of these the advantages of this approach is the high maintainability of the platform and the segregation of responsibilities of each component. It means that if something presents any kind of problem of performance or functional problems, it can be picked and solved without affecting the overall functioning of the entire platform. Of course, as everything, it also has some cons. One of these is the challenging integration. The integration among the components is a big challenge because it's not always so easy. Many times there is what is called what's wrong? I lost the presentation. Sorry. Is there anyone that wants to share the presentation?
Christos, can you reshare the presentation? It looks like it's coming back.
I moved to the slides, sorry. Okay, perfect. So I was saying the integration between the components is very challenging many times because there is what is called a full mesh. This means that all the components are used to communicate with each other. And the communication, as I said, is very challenging. And also the monitoring and logging of the events of the processes in the platform is quite hard to manage. As you can see on the left, there is the architecture. The architecture of the platform is composed by what is labeled in red. I don't know if you're able to see very well the text, but it's the entire part in charge of the collection and ingestion of the data. In green, we have all the components that are in charge of the data analytics. In the end, the green part is the real expert system that applies machine learning and artificial intelligence algorithms. There is the web platform on top in blue that presents the final UI to the clinicians and partially also to patients. And in purple, we have the authentication and authorization layer that, as you can imagine, is transversal to all the other components. The second dot point is the distributed deployment. It means that we have one cloud instance and one on-premise instance that collaborate each other. One is located in Romania and the other one is located in Italy. This enables a resilient deployment because if some service goes down on one side, other services on the other side will cover the lacking of the first one. And there is indeed a lot of redundancy between the two instances, exactly for covering and ensuring an higher resilience of the deployment. We also have the third dot point, and here I come to the third dot point. We have the Edge Cloud Continuum. The Edge Cloud Continuum covers a problem that we had to face at the very beginning of the project. That is the compliance with the privacy policies about personal data of patients that has been arranged by the clinician partners. This means that all the information, the personal information, are processed locally to the clinics, and then also after they have been anonymized or depersonalized, they are sent to the cloud. At the moment, we have 5 edge instances in Spain, in UK, in Greece, in Sweden, and in Israel. We don't have still all of them, but we will have by the end of the project all those instances that, as I said, will use an edge component that is as the architecture depicted in the left-hand side of this slide. Those edge component is actually part of the MES CoBraD platform. It presents a set of APIs, a workflow engine, and it has been implemented according to a plugin approach, plugin-based approach. This means that this is highly extensible with several business logics. That business logic, the first business logic that we are going to implement, we are implementing within the project, is the anonymization of the personal data. So the personalization of the data. Only after the plugin for anonymization and has removed all the personal information, only at the point that the data can go through internet and being collected into the cloud for data analytics, correlation analysis, and so on and so forth. The fifth hot point that we based on is the standards, is the usage of standards. We use the OpenID and the OAuth 2.0 for authentication and authorization, but we are also able to integrate systems that are using SAML. So they are all authentication and authorization standards. For the communication, for the inter-component communication, we are using REST, that is based on a standard protocol like HTTP. And for documentation, even if you cannot see in the slide, we also have the documentation, the description of the API in OpenAPI version 3, that is the standard for the REST API documentation. We also have a step of data harmonization to make everything more standard within the platform. So once the data are collected into the platform, they are also harmonized in a standard data model. And at the moment, we are exploring HL7 and Direct, that are 2 different data models, very widely used in healthcare domain. The last point is the methodological framework and practices that we are adopting. So we are adopting a continuous integration and delivery that is, it consists in the automation of repetitive tasks like the testing of the components, the integration test between the components, being sure that everything works, and it may not happen that a new deployment break up everything, and that's something that should not happen. The usage of Agile Scrum as a framework for the planning of the activities. The usage of DevOps, that is a practice that encapsulates the previous the 2 previous ones, but also incentivizes the reduction of waste, time, and effort according to the lean practices. And in the designing of each component to be totally compliant to the cloud native pattern, definition, we are using the 12-factor methodology, that is in the end a set of practices to produce a truly cloud native software solution. So this is an highlights, the highlights of the technical aspects of the MES CoBraD project. So thank you, everyone. And I leave again the floor to, I guess, Oliver, to moderate eventual possible questions that you may have. Thank you.
Yes. We will take the questions at the end. So if anyone does have questions, just place them in the chat and make it clear about which project you would like them to be addressed to. But I will not waste any more time and give the floor to the retention project and Maria Hartu.
Thank you, Oliver. Hello, everybody. Nice to welcome you also here in this event today. I will take control of the presentation and move on with the retention project, which it is coordinated by the Biomedical Engineering Laboratory of ICCS. Biomedical Engineering is a part of ICCS and the Polytechnic School of Athens. And I will be presenting a brief overview of the retention project as briefly as I can. So in retention, the health condition that we are dealing with is heart failure. Heart failure is a chronic condition. It can be really severe as the disease progresses. It is caused let's say, by the inability of the heart muscle to pump enough enough amounts of blood into the circulation. Practically meaning that the heart is unable to respond to its heavy workload, especially in conditions where high needs of oxygen are called for. So it is this can cause secondary problems, of course, and comorbidities are many in the case of heart failure. Metabolic disorders are very often as a consequence of heart failure, and of course, and more importantly, oxygen deficiency is the main problem associated with the disease, which is manifested as the disease gets more and more progresses and gets more severe, with breathing problems, shortness of breath, and inability of the person to perform even light activities, like, for instance, climb a few stairs. So it is a very serious health condition. It becomes more intense, as we said, as the disease progresses, and it is projected to get even worse in the years to come because of the aging problem, the population aging problem that we all know of. Heart failure is also associated to high mortality rates. Actually, half of the patients will eventually die from heart failure after 5 years after initial diagnosis, which is a very high mortality rate. So this is why heart failure is among the main causes of death all over the world. And it is also associated to high hospitalization rates, very frequent and long hospitalizations, meaning that, of course, that among all other things, it also imposes a heavy burden on the health systems, which is, as we said, going to get worse due to the aging problem. So what is the solution that we have designed and we are planning in the retention project? We are building actually a technological platform that consists of two components, two parts, two bigger parts. In the first part, the system functions like standards, let's say a regular telemonitoring system. That means that it can acquire, in an easy way, acquire and transmit clinical and environmental parameters that are of importance, of course, for the disease from the patient's home and present them to the physician in a regular basis or upon request even. So in this sense, it functions, it is a standard telemonitoring system, but it is expected, of course, to facilitate the interaction between patients and physicians. And also it is expected to improve the monitoring efficiency. On the second part, the system will apply advanced, let's say, advanced technologies like machine learning and data analytics on the data that will be collected. And there the aim is to try to identify possible correlations or associations that are not obvious at first sight. In this way, hopefully, we will be able to improve prognostic factors about the disease, about the progress of the disease. We hope to get information or prognosis about possible acute events, acute episodes that might follow, or even side effects or whatever. And of course, this system will hopefully allow us to get into better interventions, more personalized interventions for the patients. Now, with regard to the real-world data, that this is the common denominator among the three projects that are discussed here today. Well, it seems that there is increasing evidence in the literature that this type of data, they can have a role to play in clinical decision making. So it is foreseen that this type of data can generate added value in the predictive models that we are building when the data, the environmental or other type of data coming from real-world sources are analyzed in correlation with the clinical values that we collect from the patients. So in this way, it is expected that systems like that can lead to more safe and accurate data and prognosis and prognostic factors for the patients in one hand, and they can also lead to more effective and really personalized interventions that can be used in the daily clinical practice. So overall, the goal of the project is to, of course, improve the management of the disease in the first place, to support clinical decision making, so support physicians in taking decisions regarding their patients based on evidence, on more frequent information, more regular monitoring that will be achieved by collecting values from the patient's home, following the progression of the disease or any aspects of their daily lives, and also allow doctors to the physicians to make timely interventions before symptoms escalate. So these are the overall goals of the project. And in this sense, it is, of course, expected to have a positive impact on the primary and secondary outcomes that have been set by the project. And these, namely, have been to reduce, of course, the mortality and hospitalization rates. That would be the first outcome, the first goal to monitor, and also a number of secondary outcomes that are expected, and they are related to the quality of life of patients, their safety, their well-being, and not only the patients, but also relative to the caregivers as well, that they also suffer a lot of pressure having to take care of a relative or a person with heart failure. So we are going to test this concept, and we are planning a clinical trial that will hopefully start next February with 450 patients across in 6 hospitals across Europe. I have not made a specific reference to the partnership in the project, and this is probably my mistake. But in the chat, you can see this is the link of our website, so you can see more details about the partnership, the countries, the hospitals, and the technical teams that are involved in the implementation. And I think that, okay, these are the very basics, the basic overview, let's say, of the general ideas of the project. And now I will give the floor to my colleagues, Dr. Gouziouta and Dr. Vazdeikis, that will give you more details about the clinical aspects and the technical aspects of the implementation. Thank you for listening.
Good morning. Hello. I am Angeliki Gouziouta. I'm a heart failure and transplant cardiologist at the Onassis Cardiac Surgery Center. As Maria mentioned, my center is the clinical coordinator, and I'm representing all the other clinical partners. So having Maria addressed the problem, heart failure is a frequent, incapacitating, unstable, progressive, and a bad prognosis syndrome that causes a high logistical burden and expenditure. Heart failure affects 6.2 million American adults with an incidence of 21 per million population after the age of 65, and projection estimates that by 2030, more than 8 million people over the age of 18 will be affected. So estimating the prevalence of advanced heart failure remains an epidemiologic challenge. So with the global burden and heart failure increasing, advanced heart failure will absolutely increase in tandem. So heart failure management goals include the improvement of symptoms, functional capacity of our patients, quality of life, patient empowerment, as well as the reduction of hospitalizations and mortality, and of course the reduction, the decrease of logistical burden and costs. So to reach all these goals, an improvement in present care delivery system is required, and the vital journey for heart failure patients unfolds in the ambulatory setting. Sometimes the first diagnosis that a patient receives is in the ambulatory setting, and then is punctuated by frequent hospital visits during the compensations and back to ambulatory when stabilized. And this is the rationale for heart failure multidisciplinary integrated care, which involves close collaboration between hospital-based heart failure specialists and GPs, among many other heart failure specialists. Multidisciplinary and integrated care programs are the gold standard of heart failure patient management, and their scope can be expanded, allowing patient management at a distance, because heart failure is a chronic condition, and those patients, our goal is to identify them earlier, as we're going to see later in the presentation. So real-world data currently represent an instrument for providing the verification of both efficacy and effectiveness of investigated treatments. And despite the acknowledged despite the acknowledged value of real-world data, there is still a lack of understanding of its scope in generating evidence for treatments in addition to randomized control trials. Here you may see the heart failure epidemiology as this was indicated in a recent publication in the European Journal of Heart Failure. We see many centers of Europe and from former countries of and from former Soviet Union countries, plus Middle East. Some countries didn't put their data, but you may see at the left the incidence of heart failure, and at the right, the prevalence of heart failure in Europe. Very interesting data. So the problem is that many of these patients cannot be identified very easily, and they are missed among other doctors and among other conditions. So many societies have tried through consensus paper and through guidelines to try to identify those patients and deliver them for to the right direction. So you may see those circles that may identify these patients according to their clinical presentation, to their exams that being involved, and to their symptoms that when the disease evolves are very critical. Retention, as mentioned before, will deal with the range of advanced heart failure patients, ventricular assist device supported patient, and transplanted patients. Various systems have been used. The first one that requires the presentation of symptoms is the New York Heart Association functional class. Other stages that describe the condition of the patients for those that we are going to deal is the stage D of the advanced heart disease that requires hospital-based support, palliative care, transplant, ventricular assist devices. And the profiles, according to the INTERMACS, that is a registry that deals with the presentation of the patients and what we have to do for them, and range from patients that they are in critical cardiogenic shock to the patients that they are in advanced New York Heart Association class. So why we have chosen this chronic condition and chronic heart failure? Because heart failure is a highly unpredictable disease, and even the most experienced clinicians can be challenged by the presentation of this symptom, because when we have the onset of the chronic heart failure, then there is a clinical course that may be abrupt, like sudden death. We have many decompensations. We have the profile of the advanced heart failure patients and the therapies that we have in our as options, like the current guideline medical treatment, like the palliative care for those that they are over 70 years old, the patients that may face many hospitalizations and they have to be under the auspice of heart transplantation and the ventricular assist device implantation. So the countries, as Maria mentioned before, and the hospitals that they are going to deal with are from Italy, Greece, Spain, and Germany, 6 hospitals that they are very experienced, because actually we have a lack of dedicated heart failure centers among in Europe. And why I say that? Because not all the hospitals are implanting VADs, and not all the hospitals can face with advanced heart failure treatments such as heart transplantation. So concluding, I would like to say that we have 3 groups of patients: advanced heart failure patients that are still under monitoring with heart failure treatment, patients that supported with ventricular assist devices, and heart transplant patients. Actually, this is the first time that is going in Europe, this platform deal with heart transplant patients. And what we expect in our clinical workflow, we expect to reduce unplanned cardiovascular hospitalizations, all-cause death, and cause mortality events. So the expected improvements for patients are to reduce the emergency room visits, to improve the quality of life, because it is not only important to live long, but it is also important to live better. And the primary study outcome will be the days lost due to unplanned cardiovascular hospitalizations, and comparing those group of patients remotely with the usual care group of patients. So by enhancing patient monitoring, management, and therapeutic optimization will emerge as an improvement in heart failure patients' care strategy. Its implementation was accelerated during the COVID pandemic and will most likely be reinforced afterwards as a part of hybrid heart failure care delivery system. Artificial intelligence, it promises to become an important component of future telemedical solutions. Nevertheless, its clinical relevance still requires further validation. And when managing heart failure patients, it's not only a science, but is an art, and a human and personal approach is required. And now I'm giving the floor to our technical partner, Dr. Yannis Basdekis. Thank you.
Yeah. Okay, taking control. So thanks for inviting us to this discussion. On behalf of the technical dimension of the retention project, I'm trying in brief to illustrate some the technical dimension of it. So basically, as with the previous project, the aim of the retention project is to develop an integrated platform that gathers and analyzes health-related data, in particular for the retention for heart failure study participants and their activities. We also later on supporting the enhanced clinical monitoring of them, and later on the production of suggestions or interventions that will be considered by the clinicians of this project. So, and the whole idea is to reduce the mortality, hospitalization rates, improving their quality of life, and other, let's say, well-being factors. So technically speaking, such a continuous data collection related to the three types of the heart failure patients involves around 400 parameters. Those, the raw ones are being generated by medical devices and heterogeneous sensors, pressure meter, weight scale, oxygen saturation meter, temperature sensors, humidity sensors, etc. Smartwatch for as a wellness device, and in turn, all of them are being collected by the smartphone, later on to be transmitted to our, let's say, instances, each for each pilot. In addition, we have also combining this raw data with personal health records, and in turn, those are to be analyzed using innovative model-driven big data analytics. With as with previous project, with aiming to detect some sort of patterns that will, let's say, improve the quality of life of patients. Results of those analytics will be accompanied with by information and metrics that allows primarily the clinicians to comprehend the results of those analytics created by the machine learning projects, and this is, let's say, the part of AI explainability. We are planning to use this platform in the pilot sites previously mentioned by Angeliki across the 4 countries of EU. Now, since we are operating in European Union and having as aim this continuous gathering of medical, thus sensitive personal data, and analyzing them in a way, we are aiming in analyzing them in a way that protects the privacy and also be effective and efficient. So the architecture of such an information system that copes with these challenges must adhere to the GDPR principles as a legal obligation, and to be in line with the GDPR requirements. The retention architecture adheres to the privacy by design principle of GDPR, which is not only involves the, let's say, the role-based access control in terms of data minimization or the pseudo-anonymization processes, and later on the anonymization processes as with the previous project, but also allow this process of data handling allows the further utilization of the data, both the raw data, the personal health records, and the produced models, in a way that is also compatible with the FAIR, let's say, principle. So our design considers permissions, privileges, also complying with the Open ID. And we have also two well-known principles that accompanied by services that keep tracking of all of the triggerings of the token-based RESTful APIs in a way that we are constantly monitoring the security and privacy posture of our systems. Last but not least, we have also introduced a more, let's say, user-friendly way for the study participant to exercise their GDPR rights. Now, adhering in particular to the FAIR principle, the retention FAIR-based information model leverages the standard, the HL7 FAIR, and as far as it concerns the additional medical ontologies compliant with the FAIR, we have also concluded in applying SNOMED, ICD-10, and other, let's say, ontologies. And in the end, because in the end, we are not only considering the data, but also considering the models, the trained models later on to be applied by each instance deployed in each pilot. Last but not least, as I said, information systems, no matter how well are designed and implemented by us, the technicians, are still vulnerable both from weaknesses from their infrastructures and from the use of their end users. So this is how this monitoring activity complies with this notion. And as for the architecture, my last slide, just an illustration that glitches about both the cloud instance and the on-premise instances, each for each hospital. The global instance is the one that supports the management of the previously anonymized data, statistical and machine learning analysis, considering all the data arriving from both the instances, and later on the utilization of the results of the analytics. So basically, we are training models and later on transmitting them for further utilization by the instances. So basically, it consists of a big data analytics engine that parses and stores the data. We have also some sort of tools that manages all this learning process, basically the whole machine learning pipeline. And obviously some visual aids for the data scientists to better understand, let's say, and evaluate by visual aids the produced analytics. In the middle, we have each instance later on to be deployed to each of the pilots, the clinical side backend. Basically, this one supports the clinical side operations, the management of the patients, the management of their devices, the sensors, and the raw data that those are creating. Monitoring of the utilization, because as many health-related projects, we have the problem of continuously triggering the patients in order to be fully engaged and participate with and contribute with their data. So some sort of means of monitoring their activity is also needed. This also instance supports the applicability of the machine learning models. And later on, we have also, considering all these outputs, a decision-making tool that creates suggestions to clinicians according to some preset rules. As with all these types of instances, dashboards allow the user-friendly management of this information. And we have also a dedicated component, a security component that not only handles the end user management, but also de-identifies the data and organizes them in such a way to conform with GDPR provisions in an encrypted manner, in a separated storage, so on and so forth. Lastly, for each of the 450 study participants of the retention study, we have the patient edge, which is more or less a layer that suits all the devices and the smartphone activity. So this is where all these data are being collected, medical, behavioral, psychological, along with real-world data are being collected, associated with each of the patients. And as for the sensors, we have also the local home gateway responsible for gathering data from the home sensors and later on transmitting them to each of the instances. So more or less, this is the infrastructure. As I said, we have also another way of supporting the continuous monitoring of the privacy. So this is how a platform, a security privacy platform, paves this role. And this, let's say, the infrastructure lifecycle management will be adopted to handle the capacity of all the available resources and assets and their optimization based on the resource forecasting. And speaking about the underneath infrastructure, the system models will be executed in virtual assets. Basically, we are using virtual machines. So this is, in a nutshell, the architecture, and happy to answer any of your questions later on.
Okay, thanks for the presentation from the retention team. It's great to see so many people on the call. We have around 80 people. If you do have any questions, you can post them in the chat, and then we'll have a discussion with the 3 separate projects at the end. But now I'll pass over to our final project of the day, Monique and the resample project.
Yeah, thanks a lot, Oliver. And I'm happy to be here to tell you something about our project, which is the resample project. And of course, I do this on behalf of our multidisciplinary consortium. So you can see on the bottom right, all of the partners that are in the resample projects, and together we really cover all types of organizations and representatives throughout Europe, actually. And most of the people are here as well. So also later, if there are any questions specifically for one of the experts, we can also ask it later. So let's start first with the overview of resample. And for that, I would like to introduce you Maria, which is a patient with multimorbidity. So she has COPD and other chronic conditions. And I would like to share this video that explains what resample is about. So in this video, you get introduced with Maria, and in the video perfectly actually addresses the problem that we are facing. So the increasing number of people that have multiple chronic conditions at the same time, and the difficulty to detect what is going on with such a patient. And moreover, in these patients, it requires long-term and complex care. So on the one hand, to detect those flare-ups or exacerbations. On the other hand, we really want to limit the progression of each of the diseases that they are suffering from. So the treatment is really focusing on prevention on the one hand, the prevention of exacerbations, but on the other hand, also on the lifestyle of a patient. And for that, and to achieve that, we really need adaptive, predictive, and personalized care. Therefore, in Resample, our objective is to identify the individual multimorbid exacerbations and develop a tailored referral to a multidisciplinary adaptive virtual companionship program for patients with COPD and comorbid conditions. And to do so, of course, it's about real-world data monitoring. We gather a lot of data about that patient and its surroundings, but also from clinical guidelines, from science, and all this data is combined and used to get more insight into the progression of these diseases, but also to be able to predict exacerbations. The data is also used to determine what kind of intervention and what kind of coaching suits a patient best to keep that progression limited and to coach a person in self-management. So the solution that we propose within Resample is, first of all, that we provide a real data monitoring ecosystem that combines all these different types and changing data sources. We provide a real-time personalized prediction of multimorbid exacerbations. The third one is a secure and privacy-preserving data management platform for the decision-making. A virtual companion for the patient that can support the patient for personalized interventions in self-care and self-management. And lastly, to be able that it's actually implemented and integrated in daily care, we focus on the cross-care path integrated care system. By doing so, by working on Resample, we expect to have less exacerbations or less severe exacerbations, and that patients can have a faster recovery. So that will lead to reduced healthcare utilization, but also a better quality of life. And because they have a better self-management, also more patient empowerment. Also, we expect a digital transformation of healthcare. So now the AI will be adopted as part of healthcare, and there will be an equal role between the technology, the healthcare professional, and the patient in making clinical decisions. And where care is now delivered mainly from the hospital, it will be substituted by more home-based support. So that can really be a disruption of the current care guidelines and the daily care practice. So then I would like to go in a little bit more detail of what actually the scientific and medical problem is. So we already learned from Maria what the clinical problems or the medical problems are. And to get to know more about that, we as a consortium really go into detail and investigate what do we actually know. So we investigated the clinical guidelines, we performed scientific literature reviews, and we looked into retrospective data sets to get to know more about, for example, clinical parameters that are relevant to monitor. On the other hand, we find it very important to include all of our stakeholders in this whole process. So the second part that we are focusing on is who are actually our users? What are their clinical needs? So what we, for example, did is creating personas. We created scenarios as well as patient journeys. We expect that by creating such, so by including those users, we create a user requirement so that we expect to know what a Resample system should be about. So I put here some example user requirements. So patients shall be informed about an identified exacerbation risk and also see which factors lead to this risk. Another requirement that came about was that trends and red flags are used for communication during a consult. that the system should be suitable for people with low literacy, so general literacy, health literacy, and digital literacy, and that the system is integrated and interoperable, but also that patients, for example, have an opt-out of data collection. So based on all the clinical requirements, we gathered a complete set of user requirements to make the system of Resemble. We expect that making or with Resemble, we can really improve the clinical workflow. And I hope, yeah, here you can see the personas. Let's see, there it is. So what we now see is that Maria has 3 different diseases and she is treated for each disease separately. So it's very difficult to follow. In case Maria has a worsening or change, we do not really know now in the current disease management how she's actually doing. So that requires additional visits to the hospital, additional consults, and later, when we actually know what's going on, we can treat her for that specific condition. So it's really a reactive and quite a slow disease management. So we hope now that by having Resemble, we put the virtual companionship program really central. That means that Maria will monitor her symptoms in daily life continuously, but also that she's supported in her lifestyle and in her self-management continuously. Based on all the data that is gathered and based on the intervention outcomes, we can determine personal clinical endpoints for Maria and can detect a risk of deterioration of one of these diseases. So in this way, we know very much faster than now in current care how Maria is doing, and we can also step up care if needed. And we can provide a very much tailored care plan because we know a lot more about Maria and she knows also a lot more about how to self-manage her disease. As said, we really include all the users and all the stakeholders. So we have a continuous user involvement in all 3 pilot sites. So for example, by doing end user walkthroughs, online surveys, interviews, workshops, but also prototype testing. So this is, for example, one of the prototypes for an early contact of an exacerbation. And we started an observational cohort of 710 patients with COPD and comorbidities, and of which a selection of that cohort will be offered a virtual companionship program next year. So from the scientific point of view, it's also very interesting because we do not know yet everything. So we have to do a lot of research to make sure that this will work out in the end. For example, the things that we do not know is what kind of parameters should we actually monitor, and because they are now either unknown or unavailable or distributed. How can we protect the data and how can we organize the access control? But also for the machine learning part, there are lots of challenges because in general now the data sets are smaller and incomplete, for example. On the other hand, while using real-world data in clinical care, physicians can be overwhelmed at the moment because what should they do with all that data? So how should we represent that to enable decision-making? And current e-health applications in general provide a one-size-fits-all approach. So how can we provide a tailored approach to each individual patient? And lastly, there is an inequity in the access to and the use of e-health applications at the moment. So how can we make that more inclusive? So by using and measuring all the real-world data, we really hope to gain more insights. So on the one hand, what kind of parameters are relevant and how can we gain insight in the course of and the progression of the different exacerbations and the clinical conditions. On the other hand, we hope to gain more knowledge in timely detecting the exacerbation so we can start the preventive treatments effectively. And lastly, we hope to define the clinical endpoints so we can really monitor the individual patients and identify the optimal coaching for their self-management. So as such, the state of the art within the Resemble projects is on the one hand, the integration of the multimodal data sources. The other hand, the data-driven, evidence-based machine learning, the privacy-preserving machine learning, but also a personalized medicine approach using phenotypes of patients to provide tailored patient-centered care and coaching. the shared decision making between the patients, the healthcare professionals, and the data. So in that triangle, to really make well-informed decisions. And lastly, the deployment of the virtual companionship program on a pan-European level that really transfer institution-centered care to a more home-centered approach. So I'd now like to give the word to Serge, who is our technical coordinator of the project.
Yes, hello everybody, also from my side. I hope you can hear me well. Okay, I'll give you a brief overview on the technical side of the solution we're going to develop. So first, as Monique already pointed out, we have multimodal data, so which means clinical data, activity data and questionnaire coming from the Healthventure platform that we use for the clinical studies, but also especially with the patients. And also we try to collect additional real-world data about air quality and weather information, which is relevant for the COPD disease. So we have really multiple sources of the data and multimodal data that we have to bring together. We're based on this that we have edge nodes included in the hospital premises where all this data is aggregated for each pilot site. We use federated learning as one mechanism to train models to do risk predictions for exacerbations, and then later on support intervention suggestions and also the coaching program. But in addition, we also try to develop mechanisms based on secure multi-party computation, which use encrypted versions of the data. So this is the other aspect we're working on here. The models we're currently targeting for the risk predictions is, in the case of federated learning, we aim for explainable boosting machines mainly, because they provide glass box models and are explainable and show so far on retrospective data comparable quality to other model training mechanisms. For secure multi-party computation, it still depends a bit under which type of powerful computations are actually possible under this computation scheme. So this is still under construction, let's put it that way. We want to provide explanations. So this is provide information why a model predicts an exacerbation, what are maybe key aspects that say that there is an increased risk for predictions to be used for the clinical partners when they talk to the patients. And of course, we want to use the models that we train to propose suggestions, especially also for the shared decision making. The architecture is a microservice architecture, so we have everything or most parts inside the hospitals. So we have the edge node where machine learning components are trained, where we aggregate all the data coming from the Healthventure system, from the hospital, but also from the, let's say, environmental data services. And we have an orchestrator node that is coordinating the federated learning. So all the data remains in the hospital. We have only the models that are trained federatedly, and also the part for the secure multi-party computation that is also organized via this orchestrator node. So we have tried to make everything firewall compliant, so there are never incoming connections from outside into the hospitals, and we are based on using Docker containers to ease the deployment and installation. So if we take those figures to represent these different parts, essentially with the 3 pilot sites that we have the 3 pilot sites with the edge nodes. We have the clinical dashboard, as we call it, that is used by the medical partners to enroll patients in the clinical studies, that is all supported by Healthventure, but also that where information computed by the machine learning models will be displayed. The data collection is coming from Healthventure and the hospitals individually and the environmental data. And the orchestrator organizes all the model training, and then the models are distributed to all sites again and are used for predictions and the other type of machine learning based support like intervention suggestions. The virtual coaching is done via the Helvetia system, and which is also having the patient app where information about the patient is collected, for instance, questionnaires, but also wearable data that is collected from the patients, and then it's also included in the data that we are processing for the predictions. The standards that we use, well, as the previous project, we use HL7 Fire, we use Nomad CT and Loink. We use a standard for units, of course. We have designed all the APIs of our microservice architecture using the Open API standard. So this simplifies, hopefully, a lot of testing and yeah, shall help the integration tests. For regarding privacy, of course, we're GDPR compliant. We also have pseudonymization happening at the outside of the Edge node system. We have additional de-identification included inside the Edge node so that there's never any, let's say, identifying information still visible after maybe pseudonymization that reaches the machine learning part, so that that we can completely separate this. We use differential privacy and of course the privacy by design, federated learning and secure multi-party computation approaches. Regarding contributions, well, we're doing extensions to HL7 Fire as needed for the project to accommodate all the different multimodal data types, and maybe as a result there could be extensions proposed to the HL7 Fire, but that's still an ongoing discussion and process. We'll have to wait until the end. Regarding security, we haven't fixed it finally, but what is already decided is that we'll have a service level authorization mechanism, both to connect to the Edge node, but also between Edge node and orchestrators, and that will be based on secure tokens or API keys. So these are the main mechanisms that we're using on this level. Yeah. That's the brief overview of the technical solution, and I thank you for your attention.
Okay, thanks everyone for the presentations and that overview of the three projects. So now we move on to the second part of the session, which we have a good 30 minutes for. And I'd like to invite Monique, Maria, and Christos back into the call so we can start the discussion. If we could also stop the presentation so we can just see the three coordinators of the projects. For the participants, I can't see any questions in the chat yet, but if you do have them, please post them in the chat function that you can see at the top of the application. And if it's for a specific speaker or a specific project, please make this clear so I can relay it to the right person. But during the presentations, I was writing down some questions so we can get things started with them. It's clear that the real world data aspect is really the strong overlap between these projects and how they go about approaching the chronic conditions. But I wanted to ask the three of you first. Was there anything that you recognized in each of those projects, or any differences or similarities, any points of inspiration that you would like to start the discussion with each other on?
Can I go first?
Of course.
Right. So I think my main takeaway from the presentation is that we sort of kind of have different approaches to a similar issue. Of course, not the medical questions, but the way to approach it. MES CoBraD has a more is geared more towards the scientific method, in the sense that what we are trying to to achieve is more leaning towards assisting medical researchers perform the research which contains the analytics, artificial intelligence, and algorithms like that, and less about providing personalized healthcare. So in the way that we are doing it, I really like the implementation of the Edge module on the patient side. For us, the Edge module is on the sites side, so it's in the hospital, and the collection of data happens offline outside of the system, and uh, the that collection of data is created in a way which generates anonymized data sets. Now, there's a long discussion, and may even have another webinar uh, regarding pseudo-anonymization and anonymization, because I'm certain that you spend a lot of time discussing it, as we did. And we are trying to create anonymized data sets that are shared between the sites participating in the platform. So that's what our main focus seems to be, different to how the other projects approach it. So I don't know if Eliseos or Antonino would like to jump in to comment on that, but I think we could go. Yeah, Eliseo.
I partly agree. I think one thing that is first of all three projects have very similar parallel features that in data collection that are more relevant to the respective conditions and so forth, and how we enrich the data that we acquire, both and also from wearables or information gathered on a direct patient level through their phones or other devices. I do not think the research component, as you phrased it, is the key. The research that is applied throughout all programs, because they all mention and apply machine learning and analytics, is that it will allow improved phenotyping. So all of them have that feature that will allow us to better understand medical conditions. There is, however, in all programs also the implementation in a clinical practice. In our case, that is the final, the holy grail, as I said before, which is the expert system. Now, since we, as we have defined, we won't have a readiness level of 9 at the very end. It will be something that will be always, or at least phase updatable. But the expert system is not something just to have a better understanding of a condition, but it's actually a tool to improve clinical management. So I partly agree that for all programs, I hear that it will help us better understand the phenotyping and help in identifying management of their respective conditions. But I also see that all programs, including ours, has a direct clinical application of what we're developing.
Monique or Maria, do you have anything to come back on them points from the perspective of your projects?
Well, in our case, I think that the project is really applied. I mean, the goal is that we have a system that can actually support both the patients and their caregivers, the family members, or the informal caregivers that suffer a great pressure with having to take care of a patient with heart failure at home, and also support the clinicians into this whole great overload of work they have to deal with, to have a better insight more information, validate information from their patients on the progress of the disease, on any unexpected, let's say, side effects that might come up. So it is, in the end, what we are aiming to is a very applied and practical thing that can get into the clinical practice easily, because it does not require a huge investment in infrastructures or in machinery on whatever. It is on one hand, it's a standard telemonitoring thing that you collect data and then you hopefully try to increase the intelligence of the system by combining the data. But the data itself, it is an important factor for the clinicians to have more evidence, more information collected from their patients in a regular basis. And this is especially true in the last period that we are running with a pandemic, that we have seen. I think this is a common thing among all over Europe and all over the world, that the diseases, the normal, the chronic conditions have gone a lot. They have subsided a lot in terms of care and regular visits to the doctors and exams that they need to be performed because of the pandemic situation. So telemonitoring, although it is a very old, let's say, discipline, very old in principle, it becomes more and more important in the modern world, in the new era that comes ahead of us, unfortunately. And it can play a very significant role, but we need to be very careful on the collection of the correct variables, okay, so that doctors do not get overwhelmed with an enormous amount of information that they cannot deal with it anyway. So you have to be careful when building such systems. On one hand, on the information that you collect, the number of parameters, and also the processing. So you have to present to the physician in the end of the day something that it is easily comprehensible, that it can validate on his own behalf, and then decide on how to intervene to the patient for the best, for the benefit of the patient. So it is, in my view, it is very practical. And here, indeed, there might be a difference with the first project. I like the idea of this virtual assistant in the resample project, which is, it is a step beyond, I think, because this is a more automated, let's say, process. You have a virtual coach, as far as I understand, that can assist the patient on the fly, and this is very interesting. This is very nice to support the patients in their everyday, the exercises and then the daily living. I don't know if Yanis would like to add on that, or Angeliki from our part, from retention.
Yeah, I do have a question in the chat, unless Monique, you want to jump on that, or Ioannis, you have something to add?
Yeah, I think that a lot, I agree with already what has been said, and especially indeed, I think also the retention and resample projects are towards the application actually of real data monitoring in healthcare. And indeed, as you said, we also really focus on that patient side. So how can we make those decisions with the data? How should you visualize that? What kind of information should you provide about that machine learning models and those prediction models to the physician? But also, what should you learn and what should you show to the patient, and how can they make decisions in that triangle? So that is really the additional factor that we try to focus on that patient side as well. And I think for all of us, it's the biggest challenge is that on the one hand, we have the technological issues and challenges, and how should we make the architectures? How can we do it safely? And on the other hand, we really want to make something that is for clinical practice. So doesn't always go together. And that's also, I think, really interesting, maybe sometimes afterwards to discuss that in more detail on how do we cope with that. So the technological issues versus the clinical care practice and how we should deal with that. And also all the choices that we made, for example, for our architecture or where to put the edge nodes, there was reasoning behind it. So it's also interesting to see what was the reasoning within each of these projects to make it as it is. So more, but that's more for later, probably.
No, well, it's good to hear these ideas coming out of this first session, because this is really what it's for, to explore these overlaps and see where we're all coming at this from. I will take a question from the audience now. It is directed to the technical partners from MES, CoBraD and Resample. So I think that's Antonino and Serge. And this question comes from someone from within the retention project as a Siemens partner. And it says, I've observed that both MES, CoBraD and Resample are using the HL7 FHIR data format. I performed some research and I found out that FHIR format is not well suited for the analytics and running the machine learning algorithms. FHIR HL7 is a highly hierarchical organized data, while ML algorithms require tabular data. Therefore, I'd like to ask these two partners, one, how are they managing this aspect, data dichotomy aspect? Two, what technologies and data processing pipelines are using in order to prepare the data for training ML models? It was quite a long question. It is in the chat for these two speakers, which they can refer to it there. But I wondered if either of you have a response to this.
Yeah, I can go first. So I would like to reply first to the second question. So which technology and data processing pipelines we are using. So in terms of technologies, we are, once the data are ingested into the data lake of MES CoBraD platform, so they are already have been anonymized or pseudo-anonymized, and then we already have anonymous data on the cloud. The data are processed through a component named Airflow. Based on Airflow, it's quite spread technology and quite known technology that allows it to prepare through several steps the harmonization process. So it gets the data, it transforms it into HL7 or directly. We are in the process of deciding which of the two technology, which one of the two models we will use. And then it repushes again on the data lake in a different bucket, in a different section, to make the data available to the data analytics. I will use exactly this as a hook for the first question. So we are still evaluating. So we are at the moment, we are still not managing this aspect because we are still deciding actually which model. As I said at the very beginning, we are evaluating, during my presentation, we are evaluating HL7 and the direct as a data format model for the data harmonization. So this is a very valuable feedback. I already faced that the problem and we are still in the process of deciding. So the answer to how we are managing, we are still not managing, and for sure in the second part of the project we will do.
Yeah, and I think for Resample, Serge can best answer this question, but I believe he's already gone to a next session. So I'm not sure if his colleagues Jacob or Geza would be here to answer the question.
If they are here,
no, I don't think so.
But...
So if we, of course, you can contact me later and I can bring you into contact otherwise. Oh, there's Jacob. Yeah.
You're on mute, Jacob.
Yeah, hello everyone. Yeah, well, so we have one component that is dealing with all of the HL7 fire things. That component is developed by another partner, that is Atos. Unfortunately, I myself do not know a lot about what they are doing in that component because we are mainly working on the machine learning at the FKI where I work. Yeah, and I don't think there is someone from Artos here in the chat who could answer the question. So yeah, I think we have to leave it at that.
Yeah, I also see a hand up from Eliseos if you have a comment to add.
Yeah, hi, to that question, and I'm not an expert, but my understanding is that another requirement or benefit in having HL7 is that a lot of EMR platforms are structured around it. So if you're thinking about interoperability, it may be beneficial to have that. Now, I'm a clinician or a physician, I should say, so technical partners can, in the end, verify that, but it's a different thing to think about how you analyze the data and how you transfer it, to my understanding, or communicate between platforms. And in the end, sorry, can I hijack this comment to also ask a question? I will, okay. I don't know how the different technical partners have found existing if you want, protocols that are set and things that are not set, and whether it would make sense also across you, between you, to discuss and make recommendations about having such protocols developed based on the solutions that you're also providing for the real world data that you're finding. The example I can think for us is that each PAP device company has its own way of representing data. As things are harmonized in that way, much like we do with other types of data, like the EDF data for EEG and polysomnography, it may be useful if you put forward solutions and recommendations across consortium as technical partners. This would probably make your lives easier in the future and other people's lives easier.
Can I jump in, Oliver?
Yeah, of course. Go ahead.
Yeah. So let's start with something from the basis. The norm for 3 of our projects is the collection of data from commercially available devices, obviously associated to the context of each of the project, but still all of us have some sort of a medical nature. That in itself, provided that considering that manufacturers of devices do not easily allow raw data to be collected by those medical IoT devices, introduces a challenge for us. And this is, let's say, the part of integration. Now, seems that the 3 projects somehow gathering and repackaging this raw data into file format. Why is that happening? Because several medical devices have some sort of pre-existing structures that allows these metamorphosis to happen easily, while others do not have, but still this is relatively easy. Still the file protocol can be easily extended. So in that sense, we can easily identify structures generated by medical devices, and hopefully, because the file format is broadly supported, it is easy, let's say, to store and later on manage the medical related data. So this is why perhaps the majority of the medical related projects, let's say, go with this file format. Obviously, other later on ontologies are also compliant with this file. So in order later on to annotate further the data, it is much more appropriate to have this file as a basis. So this is why we are starting from this, let's say, first step, which is to build upon a file repository. Now, as the statement says, the machine learning cannot be easily understand this structure that file has. So yeah, some sort of data transformation must happen prior of starting to filter, to remove outliers, and later on to mess around with your data, perform the machine learning analytics, and so on and so forth. For this particular step, the retention performs this machine learning pipeline in some sort of by using some external, let's say, processes. In particular, we are using Python, which is more or less something a well-known, let's say, process in terms of supporting the full pipeline, the full ML pipeline. And later on, upon the training and also considering the performance outcome of the trained model, later on, this structure travels through a secure channel and later on can be applied. So even this Python or whatever process that creates the full steps of the ML pipeline can be explored, can be reutilized by other projects as well, assuming that these are to be applied on the same structures of the data. So this is a necessary step in order to also to be able to utilize other external tools supporting machine learning activities, even commercial ones. Obviously, in terms of Horizon projects, we are keen of using only the open source or the freewares, etc. We are not concentrating on having the big commercial ones. So the idea still is to have some sort of step that performs this data transformation, later on having a structure suitable for the machine learning pipeline. So I don't know if this answers this question.
Perhaps you have something to add, Antonino?
Sorry, I missed the original question, which is?
And it was the question posted in the chat, I think, but I'm not sure if the discussion has sort of spiraled into somewhere else from there. But if you don't have anything to add, I can ask another question. That's fine.
It went into open standards and sharing standards with others, which I think is one of the goals, and bringing other priorities from the European Commission. I think that if this is driven as far as in other areas, we're talking about data spaces and common research or AI based databases shared across the continent with anonymized data. I think our projects are kind of the start of that trend in medicine, at least for Europe.
Mm-hmm. Yeah, which perhaps leads me on to my next question, and maybe to bring Monique and Maria back in. So after now working on these projects for around 18 months, could you reflect on the trend of real-world data being used within medical decision-making and where you think this could go in the future and what the potential of that is? I can sort of hear someone, but I think there might be some problems with Maria's connection. Okay, Maria, I think you're back. We had some problems with your connection, but did you start to respond then?
Okay. Okay, you can hear me now.
Yeah, we can hear.
Okay, I was suggesting that Monique would like to go first this time.
Yeah, of course. Yeah. Yeah, I think real world data can really make a difference, and that it can make a difference that we so much need. Because indeed, with that growing number of people with chronic conditions, they have we need to reorganize and provide care in a different way, and we can only do that by empowering the patients themselves. And doing so, we need that real-world data. What we see now is actually also that, also from other studies and other projects, that we also see that it can really help patients to gain more insight in what they actually how they progress, but also to be more aware about how they are actually doing, and to support their self-management. So if you maybe if you went to a physical therapist, for example, you know how difficult it can be to do your exercises. But if you're now more coached and also see the data and also can see what possible effects it can have to do those exercises, you will be more compliant or more adherent to do so. On the other hand, we now do not have, we see that for example, patients with COPD go to a doctor once or twice a year when they are normally stable. And in the meantime, they are admitted to the hospital with an exacerbation, for example. So it's really inefficient. So why are patients not in the hospital when they actually need it? And can we also make sure that patients do not need to go to the hospital when they are very stable? So by monitoring them in daily life, we can actually make that way more efficient. And that's why we can really reorganize that healthcare of those patients, but also make all parties an equal partner in that decision making with that real world data.
Yeah, I think in your presentation you referred to it as an equal role between the patient, the clinician, and the data or the machine learning. I wondered if the other two also saw that being the direction, this idea of an equal role.
Well, from my point of view, in retention, really I cannot tell because it is too soon to see if there is any actual added value by using the real world data in the clinical decision making process or in the empowerment of the patients. We suppose that this will be the case, but still we don't know. To wait the clinical trial and see how the results perform. If we get a verification of this assumption, this is a hypothesis for the moment. I think it is a strong hypothesis.
Maria, I'm sorry to interrupt, but I'm having a lot of difficulties hearing you at the moment, and based on Monique and Christos's facial expressions, I think it's the same for them.
Maria, can you quit the call and join again?
Yes.
Thank you.
Can you hear
It breaks up. No. Can you try quitting the call and joining again, please?
Okay, and yeah, do you have a response to this, Christos, while we wait for
Maria? MES CoBraD is trying to personalize medicine, but we, in the way that we formed it, we are not involving the patient directly with the platform. Every part of decision making, which is done through and with the MES CoBraD platform, is done through the standard medical practice. We found that it's partly the reason that we're approaching it this way has to do with certain restrictions that currently are in place regarding AI applications and AI systems in general, that we are very hesitant to have systems automatically suggest something to the patient. And this is, although we do include patient feedback questionnaires that are filled in by the patients themselves and all that, these are the results are always judged by a clinician, and a clinician makes the decision. I am fully aware that the future is the direct approach, that the system will directly make suggestions and directly involve the patient into the process, and it will directly support, at least with what is standard, the patients, but with several, I would say, not certain, several ethics and legal considerations, we were a little bit hesitant to directly dive into it.
Okay. Yeah, interesting to hear also some points of differences between the projects. And I think for the rest of the audience, I'd like to make it clear that this is the first in what we would like to be a series of events between the projects, but with the subsequent events diving into more specific themes, maybe with a bit more of a specialist focus. We did have another question in the chat at the moment, which is from Florin again. He asked if we can share the presentations after today. We have been recording the session, Florin, so you will be able to watch it back online, and we can also put the presentations online. I would assume that's fine if all the speakers are okay with that. I think Maria is back. Did you want to jump in with your comment, Maria, that we were struggling to hear? Okay, we do have 5 minutes left, but yeah, go ahead.
I apologize for that. It is quite embarrassing because we are at the National Technical University of Athens and still we have connection problems, which is really embarrassing. I apologize. Anyway, I don't know, it's not important. I was just saying, commenting about the real world data that we really don't know for the moment if they will prove helpful and add value to the predictive models and the interventions that we expect, hopefully, from the project, from the implementation. But nevertheless, I believe that it is only logical to assume that all this information coming also from other sources, not purely clinical, not purely medical variables, that I am pretty sure that they will assist in having a better insight on what is happening with a specific patient, because it is not only a matter of clinical condition, health condition, it is also a matter of environmental, let's say, for instance, which is obvious, environmental aspects are very important. And you do not provide the same advice to a heart failure patient that, for instance, is living in the center of a very polluted country, in the center of a city, let's say, for exercising, and the same advice that you provide to another person with the same clinical profile that lives in the countryside. So I think that these are obvious things that you need to, we expect from using real world data. Also for prediction, I mean, it could be nice to be proactive and predict, let's say, worsening symptoms depending on other outer parameters getting into the way, but also to improve the interventions proposed to them, depending on the case, on the location specifics, home specific, socially specific. A lot of parameters can be taken into account there and make a difference. But still, we are look forward to, you know, to confirmation, to validation of this hypothesis.
Mm-hmm. And that's the potential what all the projects share.
Yeah, just to add,
Ryan is trying to jump in. We have a couple of minutes left, so
yeah, just to add of what Maria just reiterated. First of all, it is important that those publicly available data sources that all of the 3 projects are researching, that to be identified, to have some sort of how those can be used effectively and easily. And perhaps because, yeah, we are more or less targeting the same scope, to be provided, but we could just introduce some sort of an index explaining the results of our, let's say, reviews. What would be interesting is those 3 projects to outspoke about those available sources, and prior of the delivery of the related, let's say, deliverables, which is some sort of coming later on in the course of our projects. And this will allow us to have a better, let's say, overview of what it is available, and also to include those in our primary analysis. So this is one thing. The other thing is, why we are considering the world data nature of those data sources, at least in the context of retention, we are also personalizing this data. So as the example mentioned by Maria, we are still want to let's say to have some sort of a clusters, because these data more or less are associated with regions with, let's say, specific clustering areas. So grabbing this information and associating them to individual patients while anonymizing, etc., perhaps will provide better performance in our algorithms. So the idea is, if we have a common index of those available data sources, this could be reviewed easily and utilized in the context of our projects. That's it.
Okay, great. Well, I think on that note, we'll wrap up for today. I would just like to thank all the speakers and all the attendees for coming to this this webinar. I think it's been a good session and a good point to start the future collaboration. And I wish all the projects the best of luck with their work, and I'll be interested to hear where you get to in the next few months. I would remind the participants that to check out the project websites and sign up for the newsletters if you want to receive regular updates. On the sign-up form, you did tick a box that you will be informed about future events, so we will definitely be in contact with you. And yeah, thanks to the speakers of today.
Thank you.
Thank you also, Oliver, for putting this all together.
No worries. I'm sure I'll be in touch again.
And thank you, everybody, for attending and discussing with us. It was really interesting. Bye-bye.
Thank you all.
Bye.
Bye-bye.